Well, greetings everybody. So at this time I want to talk about lines, linear inequalities, and their graphs. And I will probably focus most of my discussion on the graphs. And the reason for that is because I'm doing this with a larger purpose in mind. Okay, so the larger purpose is to learn something called linear programming. Okay, and here is an excerpt from our textbook that's linked to my math lab. And as you can tell with linear programming, it seems to involve looking at the interaction between the graphs of several lines together. Okay, so even though you might not be ready for this entire discussion yet, here I have like what looks like 1, 2, 3, 4, 5 lines that are blocking off this shape right here. Okay, and they intersect at various points and so on. So then something different's going on with this picture. But the point is that to understand linear programming, we're going to have to understand what a line is geometrically, and we'll have to know something about the graph too. Okay? All right, so that's my larger purpose with this discussion that I'm about to begin. So let's start in a very basic way. The equation of a line. What does a line look like if it had an equation? So I know geometrically you know what a line is, but the equation looks like this. Y equals mx plus b. Y and x are the variables, okay? Like you could plug x in and you could calculate and you get y back out. M and b are constants. They're fixed numbers, okay? M will be the slope of the line and b will be the point where the line hits the y-axis. Okay, we call that the y-intercept of the line. So, all right, that's the equation of a line. So let's look at some examples. We always need to see examples. So I have 3 examples right here. This one, y is equal to x minus 3. Well, so in my formula up here, it says y equals mx plus b, but we'll have to read into that a little bit here. It's like m is the slope of the line, which is a measure of how steep the line is. Okay, I won't go into much detail about the slope now, but the slope tells you how steep a line is going to be. Okay, so it's m times x. What number do you see there in front of the x? You don't see one. It just says x. But if you had to say there was a number, it would be a 1. Okay, and so the slope is 1. And then it says mx plus b, and here I see 1x minus 3. So the fact that that's subtracted and not added just means that the y-intercept is negative 3, meaning it intersects the y-axis at negative 3 on the y-axis. The coordinates of that point would be 0 for x, negative 3 for y. Okay, so that's how we would read that one. We know 3 things about it right away. That it's a line, that it has a slope of 1, and it hits the y-axis at negative 3. What about this one? This one's mixed up a little bit compared to the other one, but I still see there's a number times x and then plus some other number. Okay, if you really didn't like the way it was written here, you could rearrange it a little bit and say, well, I got negative 5/3 times x and then plus 25. That would be the same thing. If that seems more orderly to you, if that seems like it compares to my formula better, then fine. This, either way you see it, is a line. The slope is negative 5/3, and it hits the y-axis at 25. Okay, so I might maybe get the idea that it might not be that hard to see an equation and recognize that it's a line and that it has a slope and a y-intercept right away. Okay. But what about this one? This one is mixed up quite a bit. Let's say we've got 3y minus 9x is 17. So when I see this one, I might kind of think about it like, well, I am expecting if it's a line that it would look like that, y equals mx plus b. And it is rearranged a fair amount, but look, if I solve it for y, I can see these other things that I want to see. Okay, so say for example, in order to get this, I add 9x to both sides. Then I get like so. And say to get this all the way, I divide everything on both sides of the equation by 3. So these are all things you can do when you solve equations. So I'm going to divide everything by 3. I get y by itself over here. What's 9 divided by 3? It's 3. What's 17 divided by 3? Well, that one would reduce to a decimal if we wanted it to, but we're going to leave it as 17/3. Okay, so this, so I take this, I kind of think about it that way, I solve it for y, and I see it the way that I want. This is in fact a line. It's y equals mx plus b. It's got the format of the equation of a line. Its slope is going to be 3, and the y-intercept is going to be 0 for x, 17/3 for y. Okay? Alright, so I saw it the way that I wanted to. Now, I'm going to talk about the graph of a line now, but I want to say that as I leave this basic idea behind, I haven't really told you much about the slope. For my discussion right now, it's not that important to talk about the slope in detail. But if you just hold it in your mind that the slope measures how steep the line is, then that's good enough for right now. Okay? Alright, so why is that? Well, because I want to really spend most of my time talking about the graph of a line. Okay? Now, let's suppose that you wanted to, given some equation of a line, know something about its graph. Okay? Alright, so you only need 2 points to graph a line, and any 2 points will do. Think about it. What's the bare minimum that you would need to know to graph a line? Like if I said this point right here is on the line, is that enough? That's not enough. 1 point is not enough. What if I said this point and this point are on the line? Then you'd know the only way you can have a line and have this point on it and that point on it is for it to look like this. Whoops. Right? Okay. I mean, that's the only way. You'd have to go through both of them. So 3 points is more than you need, and 1 point's not enough. So if you want to graph a line, you just need 2 points. All right? Now, I'm going to show you this kind of assuming that you have no other way to do this. Okay? And then if you wanted to use a graphing calculator or something like that, that would be okay. All right? But when you use that graphing calculator, I want you to know what you're looking at. So here, say we took this equation, y is x minus 3. Okay? Already, I know that that is in fact a line, that if I graph this, it will be a line. Okay? There are lots of different graphs out there, but this one will be a line. The slope is 1, and it intersects the y-axis at -3. If I just need any 2 points, I could do this. I could set up a table, I could put x and y, and I could just choose any 2 points. Choose any 2 x's you want, calculate the y's, plot those points, and you'll know what it looks like. Okay? Why is that important? Well, because in this thing that I'm working up to, linear programming, then we'll need to know what lines look like. Their equations will be given. We'll need to know something about the graphs, and we'll have to analyze what we see. Okay? So, I just want to show you, if you had no other way to do this, how you could draw the graph. Okay? Alright, so here I chose 2 points, totally at random. You could choose different points than this. You're going to get the same picture. You might find a point over here and a point down here, but you're going to get the same line. It's not going to matter. Alright? So, that's a pretty easy way to graph a line. You don't need to worry about anything else. You don't need to worry about what the slope is, or, any 2 points will work. So don't overthink it, is all I'm saying for now. Okay, what about this one? Okay, here's another line that we looked at earlier. Y is 25 minus 5/3 x, and what we determined at the time was that that is in fact a line. The slope's -5/3. It hits the y-axis at 25. Okay, but I should be able to graph this by the same method as up here. Okay, now it might be that if you choose just some random x's and you plug them in, you get the y's, you might not get nice numbers. Like when I chose 1 and I put it into this equation, the number I got was 23.3. Okay, and you can plot that point if you want to. It might be kind of hard on a graph or graph paper to figure out where 23.3 is exactly, but You know, you could do it and you could get it close and you could probably get it good enough, okay? But if you choose the right way, you could get nice round numbers, all right? So these are an example of numbers you could get. I put 0 in for x, I got 25 for y. It hits the y-axis at 25. And then I figured if I put a 3 in for x, the 3's will cancel, and then I won't have a decimal or a fraction. I put 3 in for x, I get 20 for y. So those are the 2 points I plotted. I drew the line that way. You could use 23.3 if you want to. Is it up to you? Remember, it doesn't really matter. Try not to overthink this too much. You need 2 points to draw a line. Any 2 points will do. It's just a matter of you plotting this point where it goes on your grid, okay? Now, a quick word about grids. The y-axis can have a different scale than the x-axis. Since these numbers were kind of big compared to the x's, I counted by 5s on the y-axis and by 1s on the x-axis. That's okay, you can do that. You might see graphs in the assignment where the scale's different on the x and the y-axis. Okay, it could happen. All right, so next thing, okay, let's kind of figure out where we've been in this video. Okay, there are lots of things I could teach you about a line or any other topic that we cover. I could tell you lots of stuff about it, but we always have to restrict it to whatever we need at the moment. Here's what we've done. That when we see an equation, we could recognize if it's a line or not. That's the first thing. Second thing, that if we had to draw the graph and we had no other way to do it, we could plot 2 points. Okay, and we could draw it like that. All right, the third thing will be that if we had 2 lines to figure out where they intersect each other. Okay, now that will be important because, as I mentioned, I'm working up to teaching you linear programming, and that will involve looking at how several lines interact together, with key points being where any 2 of those lines intersect each other. Okay, so yeah, that'll be an important question for us to figure out where 2 lines intersect. Okay, all right, so here I have my 2 examples I've used so far. So I've graphed each of these on their own already. Okay, I drew y is x minus 3, and then I drew y is 25 minus 5/3 x. I drew both of those by plotting 2 points and connecting them. Okay, now if you draw them together, they do intersect. Okay, I mean, imagine if you took this line that kind of goes up and to the right and you plot it together with this one that goes down and to the left, then they will cross at some point. The only time lines don't cross is if they're parallel to each other. All right, so how do you figure out where 2 lines intersect? Okay, it's not too hard to do. Here's the way that we do it. If I want to find the point of intersection, all I have to do is set them equal to each other. So if this is y is x minus 3, and I take x minus 3, and if this is y is 25 minus 5/3 x, then I say x minus 3 is 25 minus 5/3 x. Okay, and if you solve that, you'll figure out where this point of intersection is. Okay, so let's solve this. If I was to solve this equation, then it would be a matter of isolating the x somehow. So I'll move the terms with x to one side and the terms without the x to the other. So I'll get x plus 5/3 x, and then if I add 3 to both sides, I'll get 28. Okay, all right, and then I'll add these together. So 1x plus 5/3 x. Well, so that will be 8/3 x. If you add 1 and 5/3, you'll get 8/3. 3/3 plus 5/3 is 8/3. And then to solve for x, we'll multiply both sides by 3/8. And we'll get 3/8 times 20 over 1. Okay, now I know I could use a calculator to do this, but I think you should know how to do some math on your own. So let's see, I could reduce this by 4. So I get 5 and 2, right? So 4 times 5 is 20, 4 times 2 is 8. So then I'll get my answer, given that I've reduced that one all the way, 15 over 2. Okay, 3 times 5, 15 over 2 times 1 is 2. So that point right there has an x coordinate, I'm solving for x initially as I set this up, of 15 over 2, but it also has a y coordinate. So what I'm saying is, to get to that point where these two lines cross, the x coordinate is 15 over 2, meaning you go right 15 over 2, which is 7.5. But how far do you go up? That would be the y coordinate. You could find the y coordinate of this point by taking the known x coordinate and plugging it in either one of these equations and calculating for y. You can use either one. Let's use the simpler one. The y coordinate is x take away 3, so that'd be 15 over 2 take away 3. That's 15 over 2 minus 6 over 2, so that's 9 over 2. Okay, so alright, point of intersection. 15 over 2 for x, 9 over 2 for y. Okay, which amounts to this point being 7.5 spaces to the right and 4.5 spaces up, and that's where the lines cross. Okay, alright, so that's how we find out where two lines intersect each other. Set them. The only other thing is I thought I would show you some examples that appear to be exceptions to this, because I said if you're ever looking at y equals mx plus b, that's the equation of a line. Okay, but you know, there are some that appear to have equations that are lines that don't look like y equals mx plus b, and those are vertical and horizontal lines. Okay, so a vertical line, straight up and down, that's what vertical means, has the equation x equals k, where k is some number. So if you had an equation x equals k, that would be a vertical line. It would go through the number k on the x-axis, and it would be otherwise vertical. Horizontal lines look like y is equal to k, where k is some number. And that equation, if you have a graph, is a horizontal line that goes through that number k on the y-axis. Okay? Alright, so that's what the appearance equation-wise of vertical and horizontal lines are going to be. Now, examples, if I had x equals -2, that's a vertical line, and it goes through -2 on the x-axis. So here's a grid. I got my x-axis and y-axis. There's -2 on the x-axis. There's a vertical line that goes right through that point. If I had y is equal to 25, then alright, here's my grid. I'm counting by 5 on the y-axis, 1 on the x-axis. If I go to 25 and have a horizontal line go through that point, that's the graph of y equals 25. Okay, so that'll get us started. That's the bare minimum. Like I said, there's way more to know about lines than what you've seen in this video, but it's enough to, if this is our topic that we need to get to, it's enough to help us get there.